multi-sim screen? Amit?
Yes, sir.
Okay, okay.
Yes.
Now I will teach you how to perform the practical of universal logic gate on multi-sim. That is NAND gate, NOR gate. These are universal logic gate. After knowing this practical, you will be able to perform any kind of practical like OR gate, AND gate, NOT gate, XOR gate, XNOR gate, all kind of practicals. Now see, first of all, open the multisim. Now click on MISC, then click on MISC digital. Okay. Then by scrolling down, you will see where is, first we perform the practical of NAND gate. So where is NAND? See here, this one is NAND gate. So first of all, this we pick this one, that is your NAND gate, right? And this is your symbol of NAND gate. Now at the output side and input side, to verify the truth table of that particular gate, to verify the truth table of this particular gate, we have to connect some circuitry, some LEDs, some resistance, some circuitry with this, so that we will check the truth table of truth table verification of NAND gate. So we require the current limiting register. We require some current limiting register. So click on MISC, then basic, then register. Current limiting register are of 100 ohm. Okay, so just click 100. One at the output side, we can rotate them also. Now connect these with first number pin, this with the second input terminal, and this we have already been connected. This we have already been connected. Okay. Now connect some LEDs. Now connect some LEDs. So click on MISC,
Hello.
then all groups.
यही हूँ सर.
Kindly wait.
मार्कशीट दी है ना बीएससी को लेकर.
Kindly wait and click
हाँ यार
here
सर.
LEDs. One LED is red, so okay. One is yellow, okay. One is green, so okay. Okay. So 100 ohm resistance at each side connected with the positive terminal of LEDs. One LED is your green LED, one is red LED, and one is your yellow LED. The green and yellow LED is of input side and the red LED is of output side. Now we have to connect some switches, some for this. So one is this one, 0 is second one, first is 0, second input is 1, both are 1 1, both are 0 0. 0 means switch is in off condition, and 1 means switch is with off condition, because we connect switch with the required power supply. So now we require switch, so go again in basic, then where is the switch? Switch is this one. One switch is here for first input, that is A. One switch is connected here, that is of second input, B. Just change the name, B. So one switch is A, one is B. It means first input and second input. So connected with this. Okay. So both the inputs are connected. Now connect these switches with the power supply. So MISC, click on sources, then click on power sources, then click on VCC, then OK. So VCC is 5 volt, two switches are connected, two resistance of 100 ohm connected with the LEDs, and output resistance of 100 ohm is connected with red. Then we have to connect the ground. So MISC, then sources, then ground. Okay. Now you are able to see that each cathode terminal of LED we connected with the ground, and each positive terminal of the LED, anode terminal of the LED, we connected with the terminal of NAND gate via 100 ohm resistance, that is current limiting resistance. Okay, to provide the current limiting to the NAND gate, 100 ohm is disconnected. Yes. So to provide the current limiting to the NAND gate, we require 1 kilo ohm resistance. So again we go in basic, then register, then type 1K. Okay, just rotate it. So right click and rotate it. Yes. Now connect the another terminal of resistance with the ground. So we can directly use the ground here. One ground is here. So left click and then Control C, so that it will be copy. Then Control V, so paste. One more time we require. So again Control V, so paste and connect with this 1 kilo. So now the total circuitry is completed. For any logic gate, to check the truth table, for the verification of the truth table of any logic gate, you can perform the same kind of connections. Input side is connected with LEDs via 100 kilo ohm. Output side is connected with a LED via 100 ohm resistance, and input side is also with 100 ohm. Sorry, 100 kilo ohm, not 100 kilo ohm, it is 100 ohm. And switches are connected with the power supply, right? Now if the circuitry is connected, what you will see, this is a NAND gate. NAND gate means if any input is 0, output is 1. If any input is 0, output is 1. 0, what is the meaning of 0 and 1? When switches are on, it means 0. When switches are closed, like this one, both the switches are 1 1. This one is what? 0 1. Okay, this one is what? 1 0. Switch is short, it means 1. Switch is open, it means 0. Okay, so now we start, we run it. So here from this we run it. So see, only the red LED is glow. Only the red LED glow. yellow LED is off, green LED is off, it means 0 0. So what is the basic definition of NAND gate? Whenever any input is 0, output is 1. So see, both input are 0, means input side there is 0, so C output is 1. Okay, now see, first input is 0, second input is 1. So 0 1, see yellow LED is not glow, so 0. Green LED glow, so that is 1. So 0 1, that time also the output is 1. Okay, now third time the first input is 1 and second input is 0. So again see, yellow LED glow and green LED is off, so 1 0. So in this case, whenever, see very carefully, output is off when both the LED glow. So this is proof that in case of, yes, see, both the LED, both the inputs are, output is 0. So it is proof that NAND gate, in NAND gate, whenever any input is 0, output is definitely 1. And if inputs are 1, inputs are not 0, any input are not 0, then output will be 0, like this one. So now you understand everything.
Yes, sir.
So
Yes,
NAND
sir.
gate practical is completed. NAND gate practical is completed. If you really understand this practical very clearly, then type OK, OK double time in message box. So I understand that I have to go for the next practical. So kindly, very good. Okay, very good. Now once again I will be with you to teach you about how to perform universal logic gate NOR gate practical on multisim. Previously I have already been taught you about how to perform NOR gate, NAND gate practical on multisim. So now we see how to perform NOR gate. So first of all, click on MISC, then click on all groups, then go to MISC, click on MISC digital, then which logic gate you want to perform? OR gate, NOR gate, the second universal gate, NOR gate. So see, there is NOR 2, okay, that is 2 input NOR gate. NOR 2 means 2 input NOR gate. So see, this one is my NOR gate. Before starting, first we have to have the knowledge that what is the meaning of NOR gate. Whenever any input is 1, output is 0. Whenever any input is 1, output is 0. Whenever both input are 0, then only the output 1. That is known as NOR gate. Any input 1 means short. If I connect a switch with the power supply, then whenever I press any switch of any input, then output will be 0. Both switches are pressed, then also 0. If second switch is pressed, first is not pressed, then also the output is 0. Any switch is pressed, any input is 1, output is 0. So now see, this one is NOR gate. We have to perform the practical. First of all, as I have already been taught you, in case of NAND gate, connect the LEDs at the input and output side, actually the symbolic representation of 1 and 0. So go to MISC, then type all groups, then 3 LEDs we want. Let's suppose red for the output, yellow for one input, and this green for the second input. These LEDs are connected with the input terminals and output terminals with the help of current limiting resistance 100 ohm. So click, then register, then type 100 and OK. (100 ohm). This one is second 100 ohm, and one is for output. This one is your third. Okay. to show you clearly, I just this separate from each other so you can easily see the connection. Okay. Okay. Now see, each 100 ohm positive terminal, that is anode of each LED, is connected with the 100 ohm, and 100 ohm is connected at the. You can rotate it also like this one. You can rotate it also if you wish to rotate it, no problem. How to rotate? Just right click, then rotate 90-degree clockwise. Okay. Now see, one point of each resistance, one side of each resistance is connected with the input, and one side is connected with the output. So there are 300 ohm resistance. Two input side 100 ohm resistance is connected with the one terminal of each input, and the output 100 ohm resistance is connected with the output terminal. One terminal of 100 ohm is connected with the output NOR gate. Second terminal of each 100 ohm is connected with the positive of, means anode side of LED. Anode side of LED. The cathode of each LED is connected with the ground. So go to disk. Remember, power and power source, supply, ground, these all are always available in source group. So go to sources, then power sources, then ground. Yes. Kindly wait, I can separate it so you easily see this. Yes. Okay. So you are easily see the connections. Okay. So see very clearly, each negative terminal of LED is connected with the ground. This one is negative terminal actually. Okay. And each positive terminal is connected with the 100 ohm resistance. Then the second point of 100 ohm is connected at the input side from the input terminal of NOR gate, and at the output side one terminal of 100 ohm is connected with the output terminal. Okay, the same circuitry which I taught you in NAND gate is also drawn here. Okay, now we require two switches to connect the input side of NOR gate with the power supply. So go to basic and then go to switch. Okay, one switch is, let's suppose the name is A, the second switch name is B. We change the name from A to B. Okay, so one switch is this one and second switch is this one. Okay, whenever switch is on it means 0, whenever switch is off it means 1. This is 0 1 0 1 like this one. Okay, so first switch is connected with the first input side, second is connected with the second input side. Okay. Now these switches are connected with the power supply. So what is the required power supply for a logic gates? Generally the logic gates power supply is, so we click on sources, then click on power source, then go to VCC. Here automatically 5 volt VCC is there. If it is not 5 volt, then just click double left click, then we can change the power supply from here, the voltage, but we require 5 volt and by default it is 5 volt, so need not to change here. Now the current limiting resistors for the logic gate is also required, and that is of 1 kilo ohm. So go to basic and then resistor connected at the input side. Now the another terminal of 1 kilo ohm resistance is connected with the ground. So anywhere from anywhere you can just left click to ground and control C. It means it will be copy, then control V. So when you will copy, two times you need it to copy. So the 2 times you copy, just connect it. So now the NOR gate circuitry you designed. Now this is your NOR gate circuitry, complete design of NOR gate. Okay, now you wish to check it. So you have to click on run. Before run and see the result, keep in your mind what is NOR gate actually. NOR gate is what? Any input is 1, output is 0. Any input is 1, output is 0. Okay, now see. So any input is 1, output is 0. See here, no input is 1. कोई भी इनपुट 1 नहीं है तो आउटपुट 0 नहीं, आउटपुट की एलईडी ग्लो करेगी. इज इट क्लियर? नाउ लेट सपोज 0 1, दिस इज 0 0 condition. So at 0 0 condition output is 1 because red LED glow now. At condition what will happen? See, 0, A is 0, B is 1. B is 1, that's why green LED now glow, because the LED glow and the output is still 0. Output is still 0 because 0 1 condition, so output is 0 now because 1 is at input side. When any input is 1, output is 0. Now see the 1 0 case. So the second input is 1 and first input is 0. This is 1 0 case. So yellow LED is 1 because it is in glowing condition. Green LED is 0. Green LED is off, it means it is in 0 condition. So at 1 0, output is 0. Output is 0 because any input is 1, output is 1. Okay. Now the last case. 1 1. So see, first input is closed, so 1. First is closed, so 1. Second input is also closed, so 1. So both inputs are 1. Then output will be 0. Okay. So any input is 1, output is 0. In all the cases apart from 0 0, red LED is in off condition. So this is all about your NOR gate. Okay. So I think you understand about this NOR gate also. This is all about your NOR gate. Okay, dear. So we will in next lecture we will see another practical. Okay. So any problem regarding this?
No, sir.
Any problem regarding Amit and Ashish? Any problem?
No,
Okay.
sir.
Okay. Very good. Very. Take a recording of that. So kindly keep quiet and see very carefully. XOR and XNOR gate. Okay. Yes. So I am going to teach you now about the XOR gate and XNOR gate. Okay. The XOR gate is also known as exclusive OR gate. First of all, what is XOR gate? XOR gate. Which IC belongs from the XOR gate? For the 74 family, IC 7486. 7486 is related with the XOR gate. XOR gate is also known as, what is the full form of XOR gate? Exclusive OR gate. Exclusive OR gate. The full abbreviation for the XOR is exclusive OR gate. Okay. The XOR gate symbol is like this one. See, it's a little bit of like OR gate. This one, then this one. This is your output, and one more line over there. One more line over there. Okay, double lines are at the input side, and these are two inputs. So two inputs and one output. So one input is A, one input is B, and the output is Y. Okay. So this is the basic symbol of exclusive OR gate. What is the output equation we can say? So output equation is, because there are two inputs A and B, so B bar plus A bar B, A B bar plus A bar B. Just keep in your mind the equations, just try this equation. Whenever we will do the practical on software, multisim or any other software, then you will understand why we write down these equations to represent the XOR gate. So Y is equal to A B bar plus A bar B is the equation of XOR gate. The basic standard definition so that we can understand that what is XOR gate. Remember, whenever both input are opposite, output is 1. Whenever both input are opposite, output is 1. Whenever both input are opposite, then output is 1. This is the standard, we can say, definition for XOR gate. Whenever both input are opposite, then output is 1. Right. So now what is the truth table of XOR gate? On the basis of these inputs, on the basis of this definition, we can draw the truth table of XOR gate. So what is the truth table? Now we see. Kindly wait. Now this is input side, and this is your output side. One input is A, one input is B, and the output is Y. So whenever there are two inputs, there are 4 combinations, we know. Zero zero, zero one, 1 0, and 1 1. Okay. Now on the basis of the basic definition, I just draw the truth table. What is the basic definition? Whenever both input are opposite, then only both are at logic 0. It means both are same. Both are same. So whenever both are same, it means output is 1. Whenever A is 0, output is 1 because both are opposite. Now A is 1 and B is 0. Both are opposite, so again it is 1. Now both are 1, so output is 0. So see very carefully exclusive OR gate IC number 7486. So I think you understand. I once again repeat this XOR gate. XOR gate is that logic gate which is also known as exclusive OR gate, whose IC number is IC 7486. The standard symbol looks in front of you, and the output characteristics equation is y is equal to a dot b bar plus b plus a bar dot b, ab bar plus a bar b. The standard definition is whenever input are opposite, then output is 1. Or we can say whenever both inputs same, output is 0. Anything you can remember. So A and B, two inputs are there, so there will be a possibility of 4 different combinations: 0 0, 0 1, 1 0 or 1 1. So whenever 0 0 both input are same, so output is 0. 0 1 both input are opposite, so output is 1. 1 0 both input are opposite, so output is again 1. And 1 1 both input are same, that's why output is 0. So that's all about exclusive OR gate, XOR gate. Now the last gate, XNOR gate. Now see very carefully about the XNOR gate, and then so XNOR gate. Whole thing is like similar to XOR. So I just I just type. So XNOR gate, what is the IC number? So IC 74266 is the IC number for XNOR gate. IC 74266 is the IC number for XNOR gate. Okay, it is also known as exclusive NOR gate. Exclusive NOR gate. IC number 74266. What is the basic symbol of XNOR gate? It is similar to XOR, having a bubble only at the output side, which is different from the XOR gate. Yes, now having a bubble at the output side. This is your XNOR gate. One input is A, the second input is B, and let the output is Y. Let the output is Y. So what is the output? Output is just opposite of XOR gate. So we can say the output of XOR gate is AB bar plus A bar B. So now it is AB bar plus A bar B having a bar over there. So when I will teach you about how to solve the equations, then you will understand. Now directly I write down the output of XNOR gate. What is the XNOR gate actual equation? AB plus A bar B bar. AB plus A bar B bar. When we will see the practical in laboratory on simulations, and whenever we will understand the Boolean postulates and how to solve the characteristics equation, then you will easily understand all the logic gates output equation. Okay, so don't worry about that, and just focus whatever I am going to teach you to complete the basic about the exclusive OR and exclusive NOR and all other logic gates. So A bar AB plus A bar B bar is the characteristics equation, is the output equation for a XNOR gate. Okay. Now what is the basic definition of XNOR gate? just whenever both input are same, then output is 1, then output is 1. Never both input are same, then output is 1. In exclusive OR gate, XOR gate, you see whenever both input are opposite, then output is 1. But in exclusive, whenever both input are same, then output is 1. So here both input are 0 0, both are same, so output is 1. Here both input are 0 1, so both input are opposite, so output is 0. Here 1 0, so both input are opposite, again the output is 0. Here 1 1, both input are same, so output is 1. So that's all about your XOR gate. Kindly wait. I just save this file. Yes, so that's all about XOR gate. Once again I repeat, XOR gate. XOR gate is also known as exclusive NOR gate. The standard IC number is IC 74266 if we talk about the 74 family. The symbol is in front of you, just like a exclusive OR having a bubble at the output side. The output equation Y is equal to AB plus A bar B bar. The standard definition is if both the inputs are same, then output is 1. So the truth table is whenever the inputs are 0 0, because both inputs are 0 0 same, so output 1. If A is 0, B is 1, both inputs are opposite, so output is 0. If A is 1, B is 0, both inputs are opposite, so output is again 0. If A is 1, B is 1, both inputs are same, then output again 1. So these are different combinations, and that's all about